Hi there! Today we'll be taking a look at screw thread sizes and pitch, and how you can measure these using a metrology device such as a Vernier Caliper. We'll also take a look at the problems that can happen if incompatible screws and nuts are attempted to be fastened together. So, you've got a couple of threaded fasteners, like this screw and this nut. At first glance, they look like they'd fit with one another. But when you try, even though the nut may seem to be fastening onto the first couple of threads, eventually it will jam, meaning they just don't seem to want to fasten together. And you can feel that in the increased resistance. The most common reason for this is that the screw and the nut have different thread sizes, which means they're just not designed to be compatible with one another. But if they were forced to be fastened together, that's when problems like cross-threading can happen. Using a metrology tool then, like this Vernier Caliper, can prevent these kind of problems by helping you identify the thread diameter and pitch of the fasteners needed for your project. So first off, what is screw thread diameter? Well, this refers to the maximum diameter of a screw thread, or put simply, the distance from one peak or crest from one side of the screw thread to the other, like this. And this applies to both metric and imperial screws. Using a Vernier caliper to check this gives us a much more accurate measurement than with an everyday tool like a ruler. So, the major diameter of this particular screw is 9.85 millimeters. But this means we have unwieldy decimals to deal with, which is just impractical when it comes to defining thread sizes. So, instead, we would round this decimal up to the nearest millimeter, meaning we would call this an M10 screw. This M refers to the isometric thread size, which represents the screw's nominal thread diameter of 10 millimeters. Nominal diameters then are simply the way we name thread sizes to make it easier to define them. This is probably best explained by looking at tolerances. Basically, tolerances allow for undersizing and oversizing to ensure that fasteners will actually fit together. You see, if a metric machine screw and nut both had a major thread diameter of 9.9 millimeters, it would be impossible for them to fit together. There would just be no clearance room for the nut to thread onto the screw. But, thanks to tolerances allowing for under and oversizing, a screw and a nut that both have the same nominal thread size would pair together, providing of course that they have the same thread pitch. So, how do we measure screw thread pitch then? Well, luckily we can use a vernier to do this too. With a metric screw, all we need to do is measure the distance from one peak of the screw thread to the peak of the next thread along. On this screw, the distance is 1.5 millimeters, which means we now know that this is an M10 by 1.5 mil pitch screw. And for an imperial screw, we would measure an inch along the thread length and count the total number of threads in that inch distance, which means the TPI, or threads per inch count for this screw, is 16. But if the length of the thread is less than an inch, for example half an inch, then we would just need to count the number of threads across that distance and multiply it by the appropriate factor to figure out the TPI. If you're looking for a simple reference tool to double check your thread pitch, you could use a leaf thread gauge. Or, for a more precise measurement to check both screw pitch and thread diameter at the same time, you could use a ring thread gauge. So, if you've got any tips on measuring components, leave a comment below to let us know. We hope you enjoyed this video. If so, please like and share it. You can also follow us on social media or subscribe to the YouTube channel, remembering to click the bell to stay notified for more tutorials and announcements. Thank you for watching and have a great day. And let us know, what can you build?